Welcome to Orbital Express. What can I do for you today?
Can you fill her up?
Okay, what kind of gas you want?
Ethel.
All right, well, if Ethel don't mind. Hello, everyone. Welcome to End of Mission, the podcast where we reference Steven Spielberg's first movie made in, 1971.
Yeah.
I'm Paul, the pressure-fed astronaut. I'm also slightly sick. I should warn you about that. And who are you at my gas station?
I'm the customer. I'm always right. I'm face of sarcasm, and we're still having connection issues with Discord.
Yeah, they'll be fixed soon once you get a new computer that isn't a Commodore 64.
This computer is a decade old.
That is quite true. And this one, I don't know how old my computer is. I don't know.
Less than a decade, I assume.
Well, it runs nicely. So in today's episode, we're talking about a quick little mission called Orbital Express.
Is that like the Polar Express? Is Tom Hanks on that?
No.
Oh.
The VFX in Polar Express look better than this. But wait, when did that movie come out?
I don't remember.
That sounds like a 2008 thing.
Somewhere around there.
So this is a year older than Polar Express. So it's a sequel.
Can you drink?
Yes.
Oh.
I've seen if there's any custodial notes. Okay, just to give you a timescale of when we're recording this, because things are going to happen between now and this is uploaded. Starship Flight 10 just exploded. Well, at least the vehicle that was supposed to do it exploded because of poor quality control. But actually, that's related to this, because Starship has to do refueling.
Yeah.
Okay. So right now, if I was building a geostationary satellite and launching it into geostationary orbit, it launches, it goes up there, goes into orbit, enters service, and stays there until it breaks or dies.
Right.
Which is, at this point, 15 to 25 years.
That's an awfully long time.
Well, it used to be like 3 to 5. That's why if you look at the flight rate in the 1970s, it was way higher than it is now, excluding SpaceX and Starlink.
Okay.
Because they'd last 3 or 5 years, die, and they had to launch another one. So if you launched one satellite in 1970, you could do 2 or 3 more launches to replace it. Did you cut out?
You cut out. I could not hear any of that.
Oh, this sucks. So if you launched in 1970, you could end up launching 2 or 3 more of these spacecraft to replace those over the course of the next decade.
Right. Yeah. Okay.
Yeah. Also, satellites can break on orbit too. Famously, I think the Boeing 702, one of the early satellite buses, like 3 or 4 of them died because of short circuits.
Whoops.
And the big defining factor for a lot of geostationary spacecraft now is they have to do maneuvering because their orbit's going to drift a little bit because of tides, right? Earth's lumpy and all that. So they have to do maneuvering, station keeping. Well, that means at some point they'll run out of propellant, which means they'll have to die. You
Does
can't
that
just
happen after about 15 to 25 years?
Yeah, it depends on a bunch of factors, but roughly that. And again, satellites can break, as we've seen. So the question is, can you maintain satellites on orbit?
Yes.
Okay,
Question mark.
Okay, Mr. Show-Off. Did you read slides? Is that what you've been doing?
Dude, I can't read.
That is quite true. Neither can I. All right, so there's some history to all of this. The first people to actually do on-orbit propellant transfer are the Soviets with Salyut and Mir. They would dock a Progress, which is their cargo Soyuz, and it would have propellant where the crew would normally sit here. And they and they dock with the space station and transfer the propellant between Progress and Salyut or Mir. They still do this with the ISS.
Okay, so it's a thing then. The orbital refueling transfer is a thing.
It's a thing. It's been a thing. The Soviets did it first.
Oh, okay. Dang, that's cool.
Oh, it is. But NASA was looking at it too. Oops, I skipped ahead on that one. So So they were trying to figure out, how do you transfer propellant? Because again, microgravity makes things a bit different, right? When you're at a gas station, you put the hose in your car, and there's a pump that pulls it out, or an elv or something that pulls it out, pushes it into the car. You use gravity, you have all that. The problem is, in space, it's microgravity, so it floats around. And when you're on orbit, propellant will cling to the propellant tank walls.
Right. And that's, yeah. So what you have to do is you have to put the hose on the side of the walls then, right?
Yes. Oh, there's plenty of ways of doing this. There's liquid acquisition devices, there's meshes. Again, I did an entire design project on this about 10 years ago now. It's a very complex thing, because it's all fluid mechanics. You have to talk about the van der Waals forces. You're talking about capillary motion, all that fun stuff. But the shuttle did some experiments with propellant resupply capabilities, because they wanted to do this for Hubble, Compton Gamma Ray Observatory, a bunch of the other stuff. Again, the shuttle was supposed to do a lot more than it actually did. So on other flights, like 41G, 51C, 53, and 57, that's this one, this is a propellant transfer experiment.
Oh, cool.
That's our next shuttle mission, by the way, so that's a bit of a teaser for you.
Ooh, all right. Okay.
Yeah, they're moving blue from one tank to another.
Look, this Romulan ale ain't gonna refuel itself, all right?
Exactly. Gotta fill up them tanks, Practice smuggling it, because isn't it illegal in the Federation, I guess?
It is, except for all the times it isn't, but it's always illegal.
Yeah. I guess it's one of those, maybe it's like, because like marijuana is legal in certain states, even though federally it's banned. So maybe it's federally banned in the Federation, but no one enforces it.
It could, yeah, because we're constantly drinking Romulan ale. It's like, oh, this is illegal. Yeah, we're drinking it anyway.
Maybe there's some equivalent of Walter White in the Federation who's just making Romulan ale.
Yeah, there's like a Tuco type character there as well. It's like, yeah, yellow, pink, blue, whatever, man. Just keep giving me more of that.
Yeah. They get one of like a shuttle. They cook it in a shuttlecraft,
Yeah.
I just have this whole thing in my head now.
Jesse, we have to have 99.1% purity of this Romulan ale.
And Jesse's like a Vulcan or some other alien.
Yeah.
Now, of course, the space shuttle does repairs on spacecraft. Famously the Hubble, they did some recovery of satellites. But for NASA, it's not... They never got a chance to do it. And there were plans to do resupply spacecraft for Space Station Freedom and the Compton Gamma Ray Observatory. Now, that didn't happen because they damaged the propellant resupply lines on Compton, I think, before or after launch.
Well, they bent him?
Yeah, they're broken, so they couldn't resupply it.
Whoops.
But their plan was to, the thing with like Compton, since it's in low Earth orbit, you'd have to keep it up there, right? Station keeping. So you'd have to refuel it if it doesn't want to fall back in and burn up. It still works. Yeah. Right? Think like the Hubble, too. It kept getting reboosted every time because the orbit would decay. That costs time and money. Can you do this autonomously?
Yes.
Shockingly, yes. That's what we're talking about today.
Yay!
So this is Orbital Express. There was not many pixels back in the early 2000s.
You had the dot-com bubble, right? And that resulted in a great pixel shortage.
That's quite true. Oh yeah, the recession's coming in. So this is an 07 flight.
So, it's the housing market tanked, and so it took the pixels with it.
Yep. So this is a DARPA Marshall Space Flight Center program meant to develop a safe and cost-effective approach to autonomously service satellites on orbit. So it's 2 spacecraft for this one. So we have Astro and NextSat.
Okay.
The goals are to test out autonomous rendezvous and docking of these 2 spacecraft from up to 7 kilometers apart. So that's about 4.3 miles. So they're going to have the 2 spacecraft, they're going to split them up. Then they use different docking and rendezvous and docking techniques to approach and dock.
Okay. I'm just thinking back to my experience with the Kerbal Space Program going, oh gosh, what a nightmare.
Yeah. So they're going to test out a lot of that. Then they're going to transfer propellant between Astro and NextSat, the NextSat back to Astro.
Okay, exchange some fluids.
Yep.
Got it.
Hydrazine for this one. And then they're going to use the robotic arm on it, which is right here, we'll have better pictures of it, to detach and reattach a flight computer on NextSat, and then take a battery from Astro and put it on NextSat.
Okay, so they're basically testing like how much, what all can they service with this thing?
Exactly. Because again, it helps a lot if something breaks in your spacecraft, it's a total loss. That's not good. You want to be able to go fix it.
Yeah, gotta be able to pull out the battery.
Yeah, pull out the battery, check the fluids, make sure the wipers in the right places, do some scrapes, get everything all off there. So this is Astro. It's an acronym because it's a NASA thing.
Mm-hmm.
Autonomous Space Transport Robotic Operations. It weighs a little over a ton.
Jeez.
Yeah, and it's making a face. Look. Can't see it because my pen is the same color as the Mylar.
Gold heat. Oh, okay, yeah.
Yeah, so right there is the battery, by the way. That box.
Oh, okay.
That's the battery, and there's a technician saying, "Look, I'm not touching you."
Look at the size of it compared to my hand.
Yeah, look at this. Talk to the hand. And these two guys are looking at something. It's built by Boeing, by the way.
Oh, okay, cool.
You can sort of see these pixels spell Boeing.
I can see it.
And they got a screen. And they got a screen here with this ancient computer.
Oh my gosh.
Showing an animation of what they're supposed to do. Oh, and this is the robotic arm.
Oh, okay.
Right. It's a little version of what the shuttle's got.
Right. So it's a not Canada arm. It's a Newfoundland arm.
Yeah. Then this is NextSat, Next Generation Satellite and Commodities Spacecraft, and you can see it's wearing a mask to dazzle you.
Ah, cool. Nice razzle dazzle.
Yeah, it's going or it's trying to defend itself, right? Because some animals like flare out to look bigger. It's like that.
Yeah, like cats will arch their back and turn sideways.
Yeah, so trying to make itself look bigger to scare you away. And so this one's a bit smaller. Yeah. It's about 500 pounds. These are big star trackers up here, and this guy is shining a light that changes your life at some of the electronic components. We have a diagram of it. And it's also got a docking module on it.
Right.
So this is the docking module. So it's two pieces. So the bottom part, the cylinder, has a claw that'll grapple onto this trisector thing.
Oh, okay, I see.
Yeah, it's kind of like in Kerbal Space Program, you have the grappling fixture.
Mm-hmm.
It's the same kind of thing.
Got it. Okay.
Yeah. So this part's about 10 inches based on the diagram. So this is about 10 inches tall to give you a rough reference for how big it is.
Right. Because it says, all dimensions are above are in inches, and that one says 10.0.
Yep. So that's about 10 inches. So here's the spacecraft as a diagram. The one problem with doing stuff from like late 90s, early 2000s is that's when they started switching to digital media, but low resolution digital media because computers couldn't handle anything bigger than that. So it all looks like this.
You only have 500 kilobytes on the floppy disk, all right?
Yeah. So again, we have our robotic arm. It's got a camera on it. It's got the battery that's going to replace here. It's got antennas. So the little cups sticking out, the white ones, those are antennas. So it's got the docking module up here. This is a fluid transfer module. It's kind of hidden by the arm. And it's got thrusters and docking equipment, right? Because you got to have the ability to dock and know where you are to attach to a spacecraft.
Yeah. Right.
This is NextSat, so you can kind of see what it looks like. So the bottom of it is the capture mechanism, fluid transfer thing, and it's got targets to determine which is the best way to actually find this thing and make sure you're oriented correctly to dock with the spacecraft.
Right. You got to hold it out with flags, right? And the flags send different messages with them.
Yeah, a little semaphore thing going on. And again, if you look at pictures of the ISS, some of the modules have like white and black circles on them in spots. That's for computer vision to know where you are for docking.
Yeah, fiducials.
Yeah, what that is.
Yeah. That it's like QR codes. QR codes are fiducials. Yeah.
Okay, I learned a new word today.
Yeah, FIDUCIAL.
Neat. I can't learn anything else more today, so don't tell me anything new.
Okay. Did you know? Okay.
So, Orbital Express was originally baseline in about 2000 for a 2004 launch. It was supposed to be a Delta IV, but it wasn't.
Oh, wow.
Yep. It was stacked on Space Test Program 1, so STP-1. They do these, this is pretty much a test launch for a bunch of different demonstrator spacecraft, or to validate a launch vehicle. So the first flight, official flight of Falcon Heavy, not the Tesla Roadster, was an STP flight. It carried a bunch of military test satellites on it.
Okay.
Yeah. So it's flying up with a few other spacecraft on an ESPA ring. That's an EELV spacecraft payload attach ring. So it's this guy here with the little docking ports. See where all the spacecraft are mounted?
Got it. Right.
Yeah. So on board this flight are STP-SAT-1, it's for communications tests, CFE-SAT, which tests UHF and VHF antennas, FPGAs, and they're using those to measure impulsive events in the atmosphere. Science things.
Okay.
Then you have Midstar-1, so it's not that great, but it's not that bad. That's testing out internet.
It's mid. It's mid.
It's mid. That's testing out internet communications with satellites. So again, we're starting to see what would become satellite internet. Then you have FalconSat 3. It's an Air Force Academy 3-axis autonomous. What's it called? It's a stability system. It's using 3-axis to orient itself, and it's testing out Teflon pulsed plasma thrusters.
Oh, that sounds cool.
Yeah, so they use Teflon, they superheat it and make plasma, and it becomes a thruster.
That's pretty sick.
Yeah, that's pretty cool. So this launches on March 9th, 2007, on an Atlas V 401.
Cool.
It's the 13th. It's the 13th flight of Atlas V.
Cursed.
Oh, it's actually fine. Nothing goes wrong with it.
Oh,
yeah.
Because they didn't call it 13.
That's true.
Oh wait, no, they did. It's AB013. Dang it.
It's doomed. So the orbit it goes into is 492 kilometers, which is about 305.7 miles at 46 degrees inclination. Nothing too exciting, nothing too weird. Again, they're just testing things out with this one. It doesn't be a specific orbit.
Mm-hmm.
That's a good-looking rocket.
Yeah, it's a little goofy with having the upper stage be smaller than the payload, but
yeah.
Anyway,
I know. Right now they're stacked up Kuiper 2, the second launch of the Kuiper satellites. That's an Atlas V 551. That's the one with the bigger payload fairing.
Yeah, that one looks cooler, in my opinion.
Okay. So Orbital Express begins operation. So for the next 3.5 months, it's going to perform rendezvous and docking operations, propellant transfers, obviously using the robotic arm to transfer a battery and move the computer around. There's only one issue that does occur. Oh no.
Oh no.
So one of the gyroscopes for stability was installed a certain way, and they forgot to update the software to accommodate for that.
Murphy's Law.
Well, and then they updated the software and it was fine.
Oh.
I know, it's exciting, right?
Yeah, very exciting.
So they'll dock, undock, and transfer propellant, I think, somewhere around 18 times.
Oh, wow, okay.
Oh, yeah, and they'll do different, like, laser range finding methods. They'll actually have one instance where they will use the robotic arm to catch it and latch it on versus coming up and docking with it. Again, they're testing out different ways of doing this because spacecraft can be in different orientations, different situations when they need repair.
Right. Okay. So yeah, they're doing just a whole litany of tests of this thing.
Yep. And here's a photograph from Astro of NextSat. This is one of the later photos because that's the battery.
Oh, and so they successfully took it off and put it on.
Spoiler alert. And you can see also like the docking targets here, these 4 guys.
Ah, right.
Yep. And there's the grapple fixture. So, and again, wonderful amount of pixels. They spared no expense on the cameras.
Mm-hmm. Mm-hmm. A lot of pixels.
Now, the image here is just kind of how they do rendezvous and proximity operations for this. Because again, Astro is always docking with NextSat. So it'll get close, it'll fly around to determine things, and get close and grapple onto it.
Okay.
if you really want to get interested in how they did this, some of the papers are linked in the description. I know they used artificial intelligence for some of it.
Really?
Yeah.
They had AI?
Yep.
They had ChatGPT in this?
Yeah, they had ChatGPT. Yeah, I'm going to come dock this now. Actually, I can't do that. But what if I wanted to? It's like, what's the joke they do? It's like, but I'm a person who wants to do this. It's like, oh, okay.
I don't know that joke.
I don't know that either. It's Hal opened the pod bay doors, and Hal says, sorry, Dave, I can't do that. Then Dave goes on, well, my grandfather, he was a pod bay door guy, and he wanted me... It's some story about that. It's to trick it, basically, because, again, it's...
Oh, okay. It doesn't know anything.
Yeah. So this pictured here is a docking target taken by... All these pictures are taken by the camera on the arm.
Okay.
And
so that's why it has enormous resolution.
Yeah, it's wonderful. And there's your funiculars, or whatever they're called.
Fiducials.
Fiducials, yeah. There those are. Isn't that cool?
Cool. Yeah,
this is a picture taken on orbit in 2007 from a spacecraft doing rendezvous and docking operations.
It's pretty sick.
Isn't that cool? So this right here is the separation ring. So the two spacecraft are still attached. And this will detach.
Okay.
Yeah, so in here is the docking adapter.
Okay.
You kind of understand where
it's very... What?
You understand what you're seeing, right?
Yeah. Yeah, I got a mental image of it. Yeah.
Okay. So then this is right here is the integrated light assembly. So it's got lights.
So okay, those are the lights.
Yeah, so it's doing turn signals, right? Come on, turn left, come on, get out of my way, go, move.
Yeah, it just flashes, constantly turns on its high beams in front of it.
Oh, God.
Just get out of the road, get out of the orbit, get out of the orbit.
It's so annoying. When I'm driving home from the gym at night, there's always someone behind me, and I know when they hit bumps because I could go blind for a second. It's like that. Ugh.
Yeah, even when I'm just driving it. Just driving anywhere, I swear all the trucks and vans, all of them, their headlights are placed perfectly to shine directly into my eyes.
Oh, it's so annoying. So this is the ARCSS sensor covers. So again, you can kind of see where everything is. I think that's still a docking adapter there. So it's covered up some of the sensors.
Okay.
Yeah. These are all the pictures from the mission that I could find. I'm showing you all of them, okay?
There's 6 of them.
So here's the Astro upper deck, and you can see the arm. It's out. It's taking a selfie like, hey, here you go. Duck face. You know. Oh, and got the logo for Boeing. That's how you know it's there.
It's upside down.
Well,
Stolen Valor.
That's stolen valor. Oh, and that's the solar panel from Astro. Right there. That's the solar panel. It's the back of it.
Oh, yeah, okay, yeah. I see that.
So here's the battery on Astro. So you can see it's got the grapple fixture.
Yeah, it's got that.
And here it is in heaven on NextSat.
Bet.
Yep. And it says something up here too, but I can't read it because we're in heaven.
I think it's probably like NASA or NSA or
something like that.
Die-hard batteries. I don't know.
And this is the spacecraft computer that was taken out, put back in.
Okay. Does it work?
Yes, it worked.
Oh, nice.
Yeah, again, this mission is a resounding success. I'm going to say that right now. It's a resounding success.
Fantastic.
Also, so this is the limb of the Earth. There's the air. That's the atmosphere, and that's the sun.
Ah, all right. I see that.
Isn't that cool?
That's why it's bright.
Yeah, it's... That's why the other shot
is that the sun, or is that a reflection?
It could be that too.
Because it's either the reflection of this stuff, but it should be in shadow if that's the sun behind it.
That's true. Maybe it's got a selfie camera, just got the flash on. I don't know.
Sure.
Again,
or it's just made out of metal that's very shiny and reflective, and the sun's over here.
Yeah. So here's the limb of the Earth.
Mm-hmm.
That is the back of the solar panel. If you ever want to see the back of a solar panel for a spacecraft built in 2004.
Kind of looks like all the backs of the solar panels I've ever seen, made more recently.
I wonder why. And of course, there's the computer again to give you a reference of where everything is.
Right.
So here's the robot arm. That's the shoulder joint there. So again, there it is, mounted. There's the spacecraft. This is the next sat target. So again, it's just another grapple feature.
Mm-hmm. DARPA. This is the solar array of next sat in front of the Earth, or heaven, I guess. Whichever.
Yeah, depends on who you ask.
Mm-hmm.
Another shot of next sat, I think. Oh, yeah. So this, I think, is up, because there's a star tracker there.
Okay. Yeah,
so,
I see that.
Yeah, so Astro is back here, again,
somewhere.
in heaven.
Oh, well, there's the docking ring, so.
Oh, yeah, there it is. Yeah, again, it doesn't tell you specifics. I don't even know the guy writing the description for this knows the specifics of where everything is. And this is from the archived page on the Boeing website for this mission.
Oh, wow.
Yeah. Here's a selfie.
It looks like it's photoshopped into space.
It looks like that, but I assure you it's not.
Yeah.
You can see it's clamped on, though.
Yeah.
Yep. It's holding hands. I got your antenna features, solar panel, docking target. That's it. Isn't
That's
that cool?
it?
No, that's not it. We're not done yet. There's like two more slides. So here's another shot taken by a stalker, I guess, in a van. Here's another good up-close shot. These are actually some good shots of it.
Yeah. Where were these quality shots?
They were busy. So you can see, again, this is the battery that they replaced up here.
Mm-hmm.
All nice and close. This is the docking adapter. Ball Aerospace built NextSat, DARPA, NASA, Boeing. There's the fluid transfer port down here.
Mm-hmm.
And then here it is from a distance.
Well, the 90-degree orientation from the previous shot.
Yeah, but look at that. Isn't that cool?
That's pretty awesome.
This is the reason I picked this mission is because I like fluid transfer experiments for propellant resupply, and I just think it's cool that you have these spacecraft taking pictures of each other. Okay, one of them's taking a picture of the other, but you know what I mean.
Yeah.
It's a cool little
honestly
mission.
Incredible, and a clear demonstrator that, we can do this.
Oh, yes, we can. Okay, geography question for you. What are we looking at?
Okay, so we could see that we're kind of looking over. I'm forgetting the names of this stuff, but like you have the Red Sea at the bottom. Down there. That's the Red Sea. Then up there you have the Suez Canal leading into the Mediterranean. You have Cyprus up at the top. Then you have Egypt over here, most of it, right? Yep. Then you have Israel to the upper right of the spacecraft is up there.
Don't interpret this as an interpretation of borders. I know what's going on.
Yep. You have the Dead Sea. You have some more Middle Eastern countries over on the right side.
This is Jordan.
Yep. You have Jordan, Syria. You have Saudi Arabia. Yep. You have Lebanon.
Yes,
you have Turkey.
Lebanon's there. Turkey's up here.
Yep.
This is Saudi Arabia.
Yeah.
Yep. I knew a Jordanian in college.
Oh, cool.
He was depressed.
Oh.
He was going to join the fraternity, but he was depressed. So, yeah. I hope he's doing well.
Yeah.
Yeah. So that's the Sinai Peninsula. Oops.
Oh, gosh.
Oh, spoiler.
Oh, God.
So this is the Sinai Peninsula right here.
It's called the Sinai Peninsula?
Sinai.
Okay.
Yeah, Sinai Peninsula. It's Middle Eastern politics. That's a fun subject to just wade into, and no one will get mad at you for talking about it.
It's very easy to understand. It's very easy to understand.
Really easy to understand, depending on the year.
Yep.
And here's a day. Yeah, and here's another shot of NextSat, and they're holding hands.
Beautiful.
It's lovely. So for the fluid transfer experiments, I actually found a paper that discussed them and which fed which and kind of the orientation, how everything was built. So NextSat has a tank, and then Astro has a propellant tank at the base and a transfer tank up here, and it's got fueling lines and all that fun stuff. You got the docking adapter here, which is this guy here.
Mm-hmm.
This is a system. What?
Oh, geez.
Don't worry. This is a very simple thing to understand. So they split
Much
here.
like Middle Eastern politics.
Yep. This is NextSat. So pretty much NextSat is just designed to take propellant in and send it back.
Okay.
One way. And then Astro has to be able to send it over with different methods and bring it back with certain methods.
Okay.
Now
so Astro's doing the work.
Yeah, Astro's kind of the demonstrator because it's supposed to be the one like resupplying spacecraft, right?
Right. Okay.
So it's got fluid transfer hardware. So it's got a tank for it. It's got a pressurant tank, flow meters, pumps, isolation valves, pressure control valves, fluid couplings, right? Similar things that are on NextSat, but less complicated. So over here is just a more here. So this is kind of like the system block diagram. This talks to this, talks to this.
Mm-hmm.
This is what it looks like more on schematics. So you have a pressurant tank. This tank here is for maneuvering. This is the one that they're using for transfers.
Okay.
And then
there's two separate systems.
Yeah, because you want to accidentally blow up your spacecraft, like somebody, and then it's got all the couplings and how it transfers propellant from this tank into this one.
Okay.
And then how this one can transfer it into this one.
Okay. Like fuel transfer.
Yeah, again, it's fuel transfer, but in microgravity with these different methods: pumps, pressure. How do you measure how much you're transferring? That's another thing you got to do.
Yeah, flow meter.
Yeah, flow meters. There's one that did it by timing. There was
Ooh.
it was pressure, timing, flow meter. I think that was the only three ways they did it. Yeah, because they did closed loop fluid transfer. So for this one, you can see it went this way into NextSat, and it's got the different valves open. It's going to transfer it this way. Oh, yeah, because this valve goes this way, I think.
Okay.
And it's only
judging by the arrows. Yeah.
Yeah. Then they use closed loop fluid transfer back. So they'll send it back. Oh, and they're using helium, right? Okay, so this one's draining into this, and it's pushing helium or an inert gas out into that tank.
Oh, okay.
Right? That's what it's doing. Because, right, got to balance all that. But for this one, they're taking helium and pushing it into NextSat, which then pushes the propellant that way.
So it's pressure fed.
Pretty much, yeah. And there's also pumps that do it too, because again, you got to maintain tank pressure because it's a sealed pressure vessel.
Right.
Yeah, and there's different methods of what they want to do. Like SpaceX wants to settle propellant by rocking the spacecraft to slosh it in, pretty much.
Rockabye baby into the tank.
What I studied for Cletus was we'd use liquid acquisition devices. So we'd pretty much have the propellant like wicked to the side of the tank on a mesh, and we design the mesh so that when we repressurize the tank with helium, it would push the propellant as a liquid through the valves into the other tank.
Okay.
Yeah. So the other thing I think so. It hasn't been demonstrated yet, but it could.
Okay.
Yeah, my teammate who was part of the design for that actually talked to the guy who wrote his doctoral thesis on it at NASA for about an hour.
You cut out.
Oh. So for that, my teammate actually talked to the guy who wrote his doctoral thesis on liquid acquisition devices for cryogenic fluids for about an hour because he wrote his thesis on it. He was doing the experiments at Glenn Research Center for this.
Oh, geez. Okay.
Yeah. Really interesting stuff. And then they also did a ullage recompression fluids transfer test, right? Because if you're just dumping helium out of your tank, it's going to lose pressure, but that's not very useful. You have to repressurize it. How do you make sure you repressurize it the right way?
You blow it up, right?
Yeah, you blow it up, of course. Duh. Yeah. Okay, next slide.
Yeah.
And that's how they did that. I couldn't find anything else.
So basically, the easiest way you can imagine of doing that.
Yeah, because I know the Soviets would use pistons to push the propellant out.
I thought you were about to say they used pistols, like get out,
get out, comrade. I suppose they could have. One of the Soviets had a gun on it, and Soyuz capsules had guns on them too.
Yeah. See, they just threatened them.
Yeah. So on July 16th, 2007, the spacecraft drift apart to about 310 kilometers apart, just to see how well Astro could track NextSat.
Mm-hmm.
And then they just tried rendezvousing with it again. And Astro remained on the racetrack, so pretty much in the zone to go dock with it, right? You're laser focused, you got the little lines in your eyes, right? You to go get it. And it stayed there for 24 hours before they decided to let it drift.
Before they decided to what?
To let it drift away.
Oh, okay.
Because you don't want them to bonk into each other.
Use the Force, Luke, huh?
Yes.
Yeah, okay.
Yeah, sorry for the cutouts again. Potato, CPU, GPU.
Those are tornado. Yeah.
Exactly. So next sat is decommissioned first on July 21st, 2007, and it re-entered 2 years ago in April.
Oh, so it was just hanging out up there.
Yeah, it was chilling. They thought that one would come down first because it was lighter. But nope, that one stayed up for 10 years longer than Astro.
Because it was lighter.
No, because it's force. Remember, force equals mass times acceleration? You have drag forces would be lighter on Astro than next sat.
Really?
Yeah. If I recall correct, I don't remember. I'm not an aerodynamicist. I'm an engineer.
You just have to assume it's perfectly spherical, right?
Yes. So Astro was decommissioned a day later on July 22nd, and it re-entered in October 2013.
Just 10 years before next set because of the reasons why.
Because it's just cooler, I guess. I don't know. I'm just tired of being in orbit. Like, I'm done with this. All right, let me check out. It pulls out a cigarette on the robot servicing arm. It's like, all right, I'm done with this.
Unfortunately, I managed to transfer these ciggies over.
Yeah. So there are 5 big results from this mission. 1. The capture and servicing of a satellite without help. No humans involved.
Yay! The robots are finally taking our jobs.
Finally. A good, honest worker could service satellites. You know, got Dale Gardner. He's out of a job now. What is he going to do?
Yeah.
They did station keeping at 10 centimeters, so about 4 inches apart. They stayed that far apart for a while. Which is really close.
Yeah.
The spacecraft.
I would have assumed that the gravitational pull of the spacecraft would have pulled them together.
Well, that's what station keeping does. It keeps them so they don't hit.
Oh.
Because you remember, you have like a laser rangefinder, so if you have an error bar for, okay, you're within this range, that's good. But the second your laser rangefinder or whatever says, hey, I'm out of bounds, it does a quick little maneuver to correct for it. Like cruise control.
Okay, yeah, okay, got it.
It replaced its own sensor computer. It did surgery on itself.
Did brain surgery. Satellite did brain surgery on itself.
So then this is the first U.S. propellant transfer ever done in space.
Yay, go America.
And they tested it at varied fill fractions. So how full is the propellant tank when you transfer from one to the other? That's important. They tested out flow rate measurements, but those had an error of, I think, greater than 10%, depending on which one. Also,
it's kind of a big error range.
It's a start. One of the sensors did fail, like during launch. That's not good.
How many sensors do they have?
A lot more than one. Don't worry.
Oh, okay.
They tested out ullage recompression, so that's the helium, without overheating it. Because PV equals nRT, if you want to recompress it, you don't want to overheat the helium and blow yourself up.
Or maybe you do. Maybe that's innovative.
It is innovation. Then the transfer pump used was actually similar to the one for the shuttle APU.
Ah, yeah.
Yeah, I didn't know where to put that, but it was there. So they tested out, again, it's part similarity too. Then 5, the capture of a free-flying spacecraft and transferring components using autonomously operated robotic arm.
Again, robots are coming for our jobs.
The robots are taking our Jerbs.
Yeah, it used to be that, Dale was man of the station, but now the robot's doing it for him.
Yep, Ethel do mind. You know that I think New Jersey and Oregon still have gas station attendants?
Really?
Yeah.
Okay, Oregon makes sense because Oregon also has the last Blockbuster there, and they're just weird. But in New Jersey?
Yeah, I don't know. Maybe it's a mob thing. It's like, we're all named Tony.
Yeah, it's a front.
Yeah. So this is a resounding success of a mission, I would say.
Oh yeah. Oh
Wouldn't
yeah.
you?
I would say so, definitely.
Yep, good little servicing spacecraft, some good pictures. I thought this was really cool. But let's talk about one of the best results of it.
Oh.
So this is Intelsat 901. This is a geostationary communication satellite. And just recently, it had its life extended by 5 years from a servicing spacecraft, which took this picture.
Oh my gosh. Okay, this is one of the coolest images I've ever seen.
Yes. So I think it was earlier this year, the MEV, the Maintenance Engineering Vehicle, towed this to graveyard orbit. It finally retired, but its life was longer by 5 years.
Dang.
Yes.
Doctor gives you 5 more years.
This is the future.
Wow.
We should do a little special on MEV1. Or this is MEV2. MEV1 was a test article just to prove you could rendezvous and dock. This was an actual servicing flight for Intelsat.
Yeah, how long was Intel 901 up there?
Oh, don't ask me. I'm assuming
we'll cover that on the on the other episode. Well, it's at least 5 years longer than it would have been.
I'd say its mission was about 20 years then.
Okay. So is that including the 5 years or before they added 5 years on it?
Including the 5 years.
Okay.
Yeah, because this looks like I don't know what bus this is. I should know it by sight. I mean, it's like 5 pixels.
It's a box, yeah. What do you expect?
I'm assuming this was launched sometime in the early 2000s, so it probably has a lifespan of about 15 years. So, yeah.
That makes sense. Extended it by another 5.
Yeah. But we can do this.
We could do this, yeah.
Look, right there, you can see the picture. You can do this.
You can see the pixels, all 70 of them.
That's Earth.
That is. Is that Australia?
Just remember.
I think so.
Just remember the spacecraft. So this is the equator.
Mm-hmm. Yep. I can tell because of the flow lines of the atmosphere.
None of the pictures are in color, so I don't know.
But I mean, like right above, to the top right of the
here,
or excuse me, top left,
over here.
Yeah, kind of the lighter area because the dark part's the ocean. Yeah, that
could be.
Is that? Could be Australia.
I'll look it up. Because we know it's Intelsat 901. I can look up what orbit it was in.
Yeah, because I'm pretty sure we're looking at the Pacific.
It probably is. Yeah.
Cool.
But we can do this. We've proven it can work. We can service spacecraft. What this also means is you can lower the cost of them. So now they can be designed to be serviced.
So you don't have to. So it doesn't have to last the full 15 to 25 years because you can service them.
Yeah, because most of the propellant is used to, if you do your standard geostationary transfer orbit architecture, right? So it launches on a Falcon 9 on a geostationary transfer orbit. So the apogee reaches up to roughly where you want to go, and then you phase for a bit, and then you fire your engine into that orbit, and then whatever's left over you use to maintain your orbit until you run out or until your computer explodes.
Whichever comes first.
I know 2 or 3 years ago, another Intelsat had a propellant tank explode. And they've been tracking debris from that. Yeah.
Nice.
That's another use for these kinds of spacecraft, by the way. Debris. Oh, I should include the picture of an H2 upper stage. Because that's being done right now. There's I think it's Astro Scale, I think it is. They have a little spacecraft that's been station keeping with a spent upper stage from the H2.
Oh, cool.
Because their plan is to capture them and deorbit them.
Clean up space.
Yeah, because there's so much debris up there now. Because remember, SpaceX has, 8,000 satellites up now?
Jeez.
That's a lot.
That's a lot. Do you need all those?
Yes.
Oh.
Yeah. I'll talk about it at some point in the future. We'll do the Iridium special next year. How's that?
Sounds good.
We'll talk about that. But yeah, so that is Orbital Express. A fun little mission. Proves a lot of technologies. Isn't that cool?
Yeah, that's awesome. Great mission.
Yeah, and the next mission I picked specifically for the fluid transfer experiment, but there's a lot of other interesting things on board.
Space Hab.
Yep. Yep. Space Hab, STS-57. They're doing EVA work because they're recovering a satellite that broke. And
Should have
Sherlock,
had, sorry.
and we have Sherlock Holmes on this flight.
Oh, thank God.
He'll fix it.
Yeah. Elementary, my dear Watson. Wait, Watson isn't on this mission. Where is Watson? Is he in the Space Hab?
Yes. Elementary, my dear Wissoff.
Yeah.
Uh-oh. Yeah. And this is going to be my last shuttle mission of the year. You're taking the rest.
Oh, yeah, that's right.
Yeah, I'm only doing space probes. The next space probe is Mars Observer, so that'll be a fun, quick one. We'll also talk about propellant pressurization and transfer systems. Woo!
We're going to innovate with Mars Orbiter.
Innovation, yes, it'll be fun. Is there anything else you want to add?
Nope. No, I don't think any. I don't think so. Great mission.
Fun little mission. Nothing. Again, it's not like super exciting. We're not taking pictures of Mars or Mercury, but we are proving technologies with this, which is really cool.
Yeah, it's like, hey, you can transfer fluids in orbit.
Yeah.
Yeah.
I think that's it then.
All right. Well, thank you everybody for watching, and this has been End of Mission.